Hi, members of the REPU Admission Committee. My name is Maria Vargas, and first of all, I would like to thank you for giving me the opportunity to share my experience through this video. So, to the point, my research experience began 3 years ago in the lab of microbiology and microbial biotechnology in Universidad Nacional Mayor de San Marcos. There we worked with a strain of Pseudomonas aeruginosa that was isolated from another spill in the north of Peru. After screening, we found that this strain was able to produce a biosurfactant, rhamnolipid. This molecule is capable of emulsifying hydrocarbons like petrol, making it easier for the bacteria to use it as its carbon source. With the aim of reducing the contamination in the soil that is a current problem in our country. There, I could experience the whole biotechnological process, from the studying physiology of the microorganism, optimization of media and physicochemical parameters, scaling up to a 100 liters bioreactor, and the downstream process. All new adventures full of learning and excitement with successful results. However, I'm currently doing an internship in the Solar Materials Department of the Environmental Center in the Helmholtz Institute in Germany. And so far, I could say that this is the most difficult challenge I've ever had. Here, the line of research is the production of compounds using cyanobacteria as a model. Specifically, my research was focused on the establishment of an intracellular pH gradient in synecocystis using a radiometric fluorescent protein, CoGFP. Also, how this intracellular pH varies when we change the external conditions and its correlation with the production of molecular hydrogen to be used as a biofuel. As is well known, the pH in the lumen ranged from 2 to 5. That's why we needed this new no pH sensitive variant of the GFP, CoGFP. Also, synecocystis is a strain that is polyploid, so it has in between 6 to 8 sets of genomes, making its genetic manipulation really difficult, and this requires experience, hard work, and time to complete the recombination in all the genomes. This task, creating this synecocystis strain that will express the CoGFP just in the lumen, was supposed to be done by an external collaborator. Unfortunately, after 3 months of internship, this modification couldn't take place or couldn't be done successfully, which made it impossible to achieve all the principal objectives of this project. However, I could work with an strain that expressed this CoGFP just in the cytosol, or establish a new pH gradient and determine the changes in the pH at different conditions like external pH, the exposure time of the light, and intensity of the light, yielded with interesting results. While I was waiting for the strains, I got really interested in the metabolic pathway of cyanobacteria and its photocatalytic activity, coming up with new ideas for future research. Despite of this inconvenience that I had, my supervisors noticed all the effort I put on to make the project come through. This led them to offer me a position and also to make my master thesis here. all of these challenges were really useful for me because they allowed me to have this personal growth and develop my abilities as a researcher. And also, I've been put to test out of my comfort zone, which encouraged me and also helped me to reaffirm my will to go into graduate studies.